In this second part of the lecture, I will be motivating for you why we should look at styles of good reasoning other than deductive reasoning. So here is an initial hypothesis. From the previous unit, we saw that there is a notion of soundness. And soundness, again, is when an argument is both valid and all the premises are true. And when an argument is sound, that argument guarantees or logically guarantees the truth of the conclusion because the argument is valid. So that is to say that if the premises are true, then the conclusion must be. And second, the premises are in fact true. So it seems like an argument being sound is pretty good. Now you might think that the only way an argument can be good is if it's sound. So that is our first hypothesis. An argument is good just in case it is sound. Now that we understand a connective like just in case, we can break this hypothesis up into two parts. The first part is that all good arguments are sound. That is, the only way in which an argument can be good is if it's sound. And the second part is that all sound arguments are good. That is to say that it's sufficient for an argument to be good that is sound. Now, we're not going to be worried about the truth of 2, which is to say the truth of whether soundness is enough to make an argument good. For present purposes, it seems plausible that soundness is sufficient for a good argument. Though there might be certain counterexamples, and that is something that you could think of if you're interested. What we're going to be concerned with, rather, is the part 1 of the hypothesis. That is, the part of the hypothesis that claims that the only good arguments are sound. That is, the only good reasoning is deductively valid reasoning with true premises. Now, let's even put aside the idea that only good reasoning always has true premises, because, of course, in many cases we can be mistaken about the truth or falsity of our beliefs and the assumptions we use. And just because we might be mistaken here or there about the truth or falsity of the assumptions we make might not necessarily mean that we're bad reasoners. So we're actually going to look at an even weaker version of this first part, which is that an argument is good only if it's valid. So what we're going to wonder about is whether any good argument has to be a completely deductively valid argument. To put this intuitively, what we're going to wonder about is whether any good reasoning is such that the premises of that reasoning 100% deductively guarantee the conclusion of that reasoning. So this validity requirement on good reasoning, we're going to investigate. And what I'm going to give you right now is a bunch of counterexamples to this claim. So these are a bunch of counterexamples to the claim that the only good arguments are valid. Now, since the hypothesis entails the validity requirement, we're also going to be giving counterexamples to our hypothesis. Now, this hypothesis might seem natural or plausible after we've just spent an entire unit studying deduction. But what I want to point out to you is that the tools of logical deduction are actually not enough to capture all good forms of reasoning. And that is to say that I'm going to be presenting to you a few different cases of arguments which are good but not deductively valid. And so that what that will show is that we actually cannot rest content with the tools of deductive validity from the previous section. So the first type of cases fall under the category of inferences from perception and from testimony. So these are just a couple of very simple kinds of inferences we make in our day-to-day life. So, for instance, this first argument is just trying to represent the fact that often, or even usually, when you see something, you infer that that thing is in fact true. So if you see your friend wielding a knife, perhaps your friend is angry at you or really mad for some reason. You look and you see them holding a knife in their hand, okay? Having that perception, that experience of seeing someone holding a knife will likely make you conclude that that person is in fact holding a knife. Now, putting this as an argument seems kind of strange because when you see something as so, you usually conclude that it is so. However, you might not think that this argument is deductively valid because of the possibility of hallucinations. So often you might see something as being a certain way, but it's not a certain way. So for instance, if you put a stick in water, it will look bent. So if you were to conclude from the way things looked that the stick is in fact bent, then you would be the conclusion of your reasoning would be false. And similarly, whenever you have an experience, it could be that you're hallucinating. So maybe you're just imagining that your friend John is holding a knife, or you're having a hallucination. And in that case, if you were to infer that this friend is in fact holding a knife, that's a mistaken conclusion. But just because there's a possibility of you being mistaken in your experience, i.e. just because there's a possibility of, say, hallucination, doesn't mean that in typical cases, and maybe the grand majority of cases, from your experience, you are warranted in inferring conclusions about the way things are. So inference from perception is an example of good reasoning, which is not deductively valid. Now, some very similar type of reasoning is not based on how things look in perception, but based on how people tell you things are. So, for instance, my parents told me that I was born on March 9th, 1991. Now, I don't have any direct perception of that event. I mean, maybe at the time I did, but I certainly don't remember it. And it was certainly not a clear perception. So it seems like the main reason I have for believing I was born on this particular day, on this particular year, was that my parents told me. So that is to say, the premise of that reasoning is testimony, what someone is telling me. And from the fact that someone is telling me something, in this case that my parents told me that I was born on March 9th, 1991, I can safely conclude that that is true. Now, just like in perception, you might be hallucinating, you might be misled by your perception. Similarly, it's obviously possible for people to lie to you, or for people themselves to be mistaken in what they're saying. So that is to say that my parents can tell me something about when I was born, but that thing can not be true. So therefore, it seems like this kind of reasoning from what people tell me to what is the case is not deductively valid. However, in many, many cases, when people tell us things, we simply take them at their word. So for instance, it would be pretty wild for me to doubt what my birthday was, just because it's possible that my parents could be lying. So in many cases, we take other people's testimony at face value. And so it seems like this kind of reasoning is good reasoning, but not deductively valid. So it seems like here we have cases of good reasoning that is not deductively valid. So here we have some counterexamples to our hypothesis. Now, we're not going to be saying really anything more about perception and testimony in this class because these are more deep philosophical questions. But what we will be talking about are two other types of reasoning, which is good but not deductively valid. Now, in Unit 4, we're going to be talking about decision theory, or the kinds of reasoning that go into making decisions about how to act. And so to foreshadow for that unit, which is again the final unit, so that'll be in about a month or so, here we can think of decision making as involving certain kinds of inferences that are good inferences about what to do, but which deductive logic, which we saw in the previous unit, doesn't really shed much light on. So imagine that I'm deliberating about where to go out for dinner. So the first premise, so to speak, is that I want to go out for dinner. Now the second premise is that I believe that there are better restaurants in New York than in New Brunswick, New Jersey. So given this motivation I have to go out for dinner, and given this belief about where the best restaurants are, I conclude that I will act in such a way that I will take the train into New York. Okay, so this conclusion is kind of a conclusion about what is the best way for me to act, based on premises about what I want and what I believe. And it seems like this is a pretty good chain of reasoning, but it's unclear how this is deductively valid. So we're going to need a better theory of how to capture the goodness of this reasoning in decision making. Another example is as follows. So the first premise is that I want to visit my friend in LA. Now, if I take the plane, there's a chance it will crash, which is really terrible. I.e., the case in which I'm on a plane and it crashes is an incredibly bad outcome. But it's a very, very small chance that the plane will crash. Now, if I'm so afraid of taking a plane, one alternative is I could walk from the East Coast here all the way to LA. Now, if I were to do that, there's no chance at all that I will be in a plane crash. But it's certainly going to take an incredibly long time. So if these are kind of the two options, I take a plane or I walk, even though there's a chance of a really, really bad outcome in one of those cases, that chance is very small and is overall better than not risking it, but having to walk for, say, I don't know, a month, 2 months, however long. So therefore I conclude that I'll actually will take the plane. Now this seems like very good reasoning, but it is not deductively valid. So here, in the kind of reasoning we make in making decisions, we have reasoning which is good, but not deductively valid. So this is a type of reasoning we'll have to build further tools for, and we'll see in Unit 4 how that works. Now, finally, we have some additional counterexamples to our hypothesis that good reasoning has to be deductively valid. And these counterexamples involve induction. And inductive reasoning is precisely the kind of reasoning which we're going to build the tools of probability theory in this present unit in order to make rigorous sense of. So here are some examples which illustrate the two main types of inductive reasoning. The first one has to do with inferring something from an entire population to something about a sample of that population. So consider the following argument. So premise 1, I think most birds can fly. So with a bit of creativity, I'm sure you can think of some examples of birds that can fly, for instance, penguins or ostriches. But nonetheless, most types of birds, maybe even the grand majority, are able to fly. So given that belief about the entire population of birds, i.e. that most birds can fly, and then given a second premise, which is that here we have something Tweety, a bird in front of us. So I'm holding a bird, Tweety, in my hand. And since I know this thing Tweety is a bird, and I know that most birds can fly, it seems like it's pretty good for me to conclude that Tweety can fly. It seems very likely that this sample of a bird can fly, given that the grand majority of birds can fly. However, this argument is not deductively valid because it's possible, for instance, that Tweety is a flightless bird, for instance, a penguin or an ostrich, like I mentioned. So just because most birds can fly and Tweety is a bird doesn't logically or deductively imply that Tweety can fly. However, this still seems like a pretty good argument. If you know most birds can fly and you run into some random bird, it seems like a pretty safe conclusion to draw that this random bird, in this case we've called him Tweety, can fly. So, to put it another way, these premises make the conclusion very likely, but they do not deductively guarantee it. Here's another example, and here we infer something from a sample or a number of samples to an entire population. So we have as our premise, most birds that I have observed so far can fly. So hopefully you can relate this to your own life, which is that the grand majority of birds you've seen are birds that can fly. And now from that observation of the sample birds, you can conclude that in general, most of all birds can fly. Now, just as with this example here, this second argument, this second inference from a sample to a population is not deductively valid, because it might be that there's tons and tons and tons of birds you haven't observed, and all of them are ones which can't fly. So maybe on the far side of Mars, there's millions of types of birds that none of them can fly, and no one has observed them yet. So in that case, even though most birds that we've observed so far can fly, it's still not the case that most birds overall can fly. But nonetheless, just because this premise does not logically entail this conclusion, doesn't mean that it's a good argument. In fact, it seems like if it's true that most birds you've observed so far can fly, especially if you've observed a lot of birds, it seems like that makes it very likely that most birds overall can fly. So in describing the goodness of these arguments, I've appealed to the ideas of the premises making the conclusion likely. That's to say that, and the notion of likely has to do with probabilities. How likely or how probable is the conclusion given the premise? So these counterexamples here, where the premises make the conclusion very likely yet do not deductively guarantee it, are the type of counterexamples to the validity requirement, the alleged requirement that all good arguments are valid. And these are the counterexamples that matter for moving forward in the present unit, because what we're going to do is we're going to build on the tools of formal deductive logic to develop the formal tools of probability theory. And starting next week, we'll be developing those formal tools, and those will help us capture how an argument can be inductively good or inductively strong. So in the next video, in the third part of this lecture, I will introduce to you in a bit more detail the notion of induction.